Welcome to WebRTC Live. In WebRTC Live, we cover the latest technical topics and business use cases for WebRTC and live video. As always, this episode is brought to you by WebRTC.Ventures, leading integrators of WebRTC video into your custom application.
Welcome back to WebRTC Live. I'm your host, Arin Sime, founder and CEO of WebRTC.Ventures. WebRTC.Ventures is a custom design and development agency focused on building live video applications. We're here to help you take your application live. You can learn more about us at WebRTC.Ventures. In today's episode, Chris Cunningham, senior software engineer at Google, is going to tell us what WebRTC developers need to know about WebCodecs. So this is going to be, I think, a really interesting conversation. Really pleased to have Chris here as a guest for us for the first time on WebRTC Live. Thanks so much for joining us today, Chris.
Thank you so much for having me. I'm really happy to be here and to get to talk about WebCodecs, what we built, and how it can be used or useful to WebRTC developers.
Awesome. Looking forward to it. All right. Well, let's jump right in. And for those watching live today, you can feel free to put in any questions you have in the chat, and we'll make sure to address those with Chris at the end. All right. Take it away, Chris.
All right. So what WebRTC developers need to know about WebCodecs is, of course, not all that WebRTC developers might need to know, but it's a couple of kind of high-level discussion points for reasoning about what RTC apps this makes sense for, what scale this makes sense for, and how you should reason about where we're at now versus maybe where we're going. As the structure of the talk, I'm going to do a quick intro on what WebCodecs is and where it's available, and then I'm going to cover kind of the interesting things about what you can do with WebCodecs and RTC applications. Given the time here, I'm not going to get super deep into technical aspects of the API. If you are interested in that, I did talk more about the code at the IIT WebRTC talk just last week. I think recordings of that are coming online soon. Look out for that. But then also, I'm very happy to answer any deep technical question you might have after the presentation. So what is WebCodecs? WebCodecs is like FFmpeg or AV Foundation, Media Foundation, but for JavaScript. It's going to expose encoders, decoders, video frame, these sorts of interfaces at the JavaScript level. And it's actually built on top of the APIs I just mentioned, which have for a long time been dependencies of browsers for things like WebRTC and the video tag. And like those interfaces, WebCodecs is not about a specific codec. It is a unified interface for using a variety of underlying codecs like VP9 or AV1, etc. So WebCodecs is available now. It shipped in Chrome 94. It's also available in Edge. Firefox is planning to implement in the coming year. No word yet on Safari. But Safari, I can at least say, is aware of the API. They gave us feedback as they were developing the specification, and they are not unsupportive. So we will see. Folks are using it now, as it is available. This includes conferencing apps like Zoom, as well as streaming use cases like remote desktop, like Citrix would be an example of them. On browsers where WebCodecs is not supported, you have the option to do, fall back to WASM, which is what Zoom is doing, or you can do, WebRTC if that's your existing pipeline. This is a really common question, so I thought it'd be important to throw this in here. What codecs does WebCodec support? Like any media API on the web, the codec support is going to vary across browsers and to some extent across the platform, even for a common browser. This is this situation with Chrome today. You can see that on the decode side, we support basically everything that the video tag and the audio tag support. I would say actually exactly everything that they support. And then on the video encode side, we are almost at parity with WebRTC. And you can see we have some codecs being added here in the coming quarter. A reminder, since support will vary by platform, we offer a static API to check in advance of trying to use a codec or configuration that what you're hoping to use is actually supported on the system where you hope to try it. Okay, so let's get into the RTC side here. WebCodecs is interesting for folks who want more control over the stack. If you've ever uttered the words, "I wish our WebRTC would let me, X." So an example of things that could be in that category, if you wanted more control over the way that WebRTC does adaptation when it detects fluctuations in your network quality or CPU overuse, WebRTC will adjust today your encoding settings and your resolution and your frame rate, but maybe that's something that you would like to do instead. You think that you could do a better job than WebRTC, or use a strategy that makes more sense for your app. Kind of a specific another example related to that would be specific encoder settings. So if you wanted to configure a specific flavor of SVC, or if you wanted to customize the latency of the encoder, or if you want to be 100% sure that you have hardware encoding because you have your own WASM software fallback. And so if this machine doesn't have hardware acceleration for the codec you're interested in, that's fine, but you don't want Chrome's software fallback. You want to use your own. You have these options with WebCodecs. And then finally, another example would be the rendering. So WebRTC makes its own decisions about how many frames to decode in advance of showing a frame, how to reconcile the kind of push versus pull with audio, where the network is pushing packets as they arrive, but of course the operating system's play out is a pull model where you have this buffer. You've got to meet this deadline to render audio every couple of milliseconds, and so WebRTC in Chrome has implementation details that will compress the sound or stretch it as needed to kind of reconcile the jitter of the arrival of audio versus the play out. These are also things that you could customize with WebCodecs. In addition to that, there's a whole other category of WebRTC uses that would be really interested in WebCodecs, which is folks that want just a narrow piece of WebRTC, for which WebRTC as a whole is kind of a behemoth and not necessarily a good fit. So these are examples like cloud gaming or remote desktop. These both kind of generically are in the low latency server client streaming setup. So they want to run a server. They want low latency download. They want low latency rendering, but they don't care about peers and ICE and DTLS and all these other things. So should you use WebCodecs? Maybe you're in one of those groups. Maybe you're not quite. For group one, I would say that with great power comes great responsibility, right? If you can customize all the things I described and more, but at the expense of rolling up your sleeves and doing it yourself, building an app, kind of from scratch on top of starting with the codec level. And this is a significant undertaking, right? Like the WebRTC team at Google, or even just like the video tags, video stack team at Google, which builds applications on top of starting at the codec level. These are dedicated development teams, staffed with, let's say, 10 people, just to this task of, building the app and then keeping the lights on. So, Zoom obviously was able to do this, but I want to call out that WebCodecs is, this would be a significant re-architecture if you have an existing RTC stack with WebRTC. And then for group two, WebCodecs is actually combined with other APIs like WebTransport is actually an architectural simplification. So here you maybe don't need a huge dev team. You can actually transition to WebCodecs and really simplify your architecture by dropping that dependency for bringing in WebRTC and all of its protocols at the server and that sort of thing. You can deliver the stream with the transport of your choice, be it you could still use RTC, you could use RTC data channel, you could use HTTP if that made sense for you, probably not. You could use WebTransport, be a very interesting choice, and then you can decode WebCodecs and render with Canvas or the media stream track. So what about everybody else? These are folks that want to use just some part of WebCodecs, but they don't want to discard the whole of WebRTC. They don't want to re-architect their entire stack. It is too early for us to make like firm commitments here, but I can say that we're in the early stages of exploring further WebRTC WebCodecs integration. So for instance, maybe one day it will be possible to use WebCodecs video encoder, which you construct and configure according to your specific needs in combination with an RTC RTP sender. So stay tuned. You can already see that evolution taking place with the media capture transform specification, which I've linked here. And this is also known as breakout box. Specifically, the media stream track processor API is going to allow you to take a get user media stream. This is the camera or the get display media stream for screen sharing. Wrap that in the media stream track processor, which will then feed out video frames, which are the WebCodecs video frame primitive. And using the video frame, you can retrieve pixel data in the native pixel format, so probably some YUV format in the case of the camera, and manipulate the video frame, like doing background replacement using WebGL or WASM, in advance of sending it back through the rest of the WebRTC pipeline, which, instead of using media stream track processor, it's just what you start with, then you manipulate the frame, and then you send it back to the pipeline by again creating a media stream track using the media stream track generator, half of the breakout box. Of course, this API is also interesting for folks that just want to use WebCodecs without RTC, but it's an interesting example of where WebCodecs and RTC are kind of coming together. And that's it. That's my slides. So I wanted to open the floor for questions.
Thank you so much, Chris. Really appreciate you giving us that quick overview of WebCodecs. And I think it is really interesting whether, as a WebRTC developer, whether this is something you would be interested in working with right now, or kind of at least being aware of these capabilities that are coming in the future. I think one thing, a little logistical note, and this is on me that I forgot to say, Chris, is that us WebRTC developers, we're a little sensitive about the Z word. And you mentioned that big company with that meeting tool that's become so ubiquitous and become a verb of its own, really. But I'm just kidding, but glad that you mentioned it, because it's interesting. Like you said, one group of people who may want to use this are companies with a really large development team and building a really unique tool there. I guess it makes me think about a couple things, different use cases that this could be applied to, but also kind of starting at a little bit of a higher architectural level. For people who are integrating sort of current WebRTC into their web applications, say, they're often looking at different choices like using a commercial CPaaS or an open source media server. They're trying to decide which way to go there. We could think of both of those really as like a layer of abstraction above the WebRTC standard itself, right? There's some other servers in between that help us with things like group chats and scaling and stuff like that. And so I guess generally speaking, if somebody is using one of those services now and they're happy with what they have, then we could say that for at least right now, WebCodecs is not really relevant to them, right? However, if they, for whatever reason, unique to their use case or performance that they're trying to get out of it, they're going to libWebRTC, they're making changes, they're recompiling it, then this is something that maybe allows them to make some of those same changes through the WebCodecs API in terms of how they handle video frames and performance and stuff like that, right?
Yeah, I think that's a fair description. If you are happy with WebRTC, no need. We like WebRTC. I work with those guys. WebCodecs is not the WebRTC killer. So yeah, by all means, feel free. But yeah, if you camera turned off, apologies. If you are already customizing WebRTC, like that sounds like the kind of folks that this might appeal to.
Yeah, absolutely. And yeah, we were talking a little bit before the episode started, and you talked a little bit about like why, let's take first the example of a large meeting tool company. Pick Zoom or pick anybody. Why in the past they might have avoided using WebRTC and done something, a more homegrown stack themselves. And now, if we want to try and duplicate some of that through WebCodecs, what sorts of things, in particular, do you think a company like that, a large meeting tool company, is going to be looking to utilize WebCodecs for?
Yeah. So I don't really know the background with Zoom and what they,
Sure.
but I can expect, as probably most of you can, that it was about differentiation. Like if you use WebRTC, which is great, but high level API, and you want to do again a new feature, the secret sauce of your app is that you show way more video tiles than everybody else, or that you have better innovations in transport, let's say, then you have to decouple from WebRTC, because you don't want to build your secrets into a library that everybody uses, and you also obviously don't want to wait
Right.
for that same library to build those secrets into it for you, and then everybody uses them, right? So
Right.
yeah, for
Yeah.
Zoom in particular, WebCodecs is about performance. So they can use WASM, and WASM performance is viable, especially with introduction of SIMD. And they continue to use WASM as a fallback. But WebCodecs alone is going to offer them access to those platform encoders and decoders, which is going to be great for CPU load reduction, especially in low-end devices, and also power efficiency.
There's a lot of use cases where you really care about the performance of one stream in particular, like maybe a broadcasting type of scenario, or an educational scenario where the professor's video stream is more important than everybody else's. Can you use kind of WebCodecs to get some extra boost, just sort of in particular cases, and prioritizing different streams over another? Is there a particular advantage there over WebRTC?
I think that it's a simplifying thing. This is kind of the streaming case, right? The one to many.
Sure. Yeah.
Yeah. My understanding is that WebRTC is actively like filling that role for a lot of apps and doing a fine job. But and I should mention, my background is not in WebRTC, so I am sort of repeating what I've heard from other folks on this particular point. I've heard that WebRTC doesn't do a great job at scaling past a certain number of participants. So if you have a couple hundred, you can get away with this. If you have 1,000, or many thousand, the infrastructure really starts to choke. This is another case where you don't care about all the you don't care about ICE. You're not doing firewall traversal. You don't really care about peers in the same way. There's not really a codec negotiation happening in the same way. So WebRTC has a lot of things you don't need. So yeah, with WebCodecs, this I don't technically understand what the limitations of WebRTC are that lock in, that have that threshold of a couple hundred. I know that with WebCodecs and WebTransport, or whatever transport you decide to use, you're no longer constrained by those limitations. So yes, it can offer better performance because you can design it yourself to perfectly suit your needs, and you can discard large pieces of WebRTC that you're not interested in using.
Right. Right. Yeah. Excellent. That's great. A couple questions from our viewers here. Alberta would like to know if there are any examples in the real world of web codecs being used now, or perhaps that you would anticipate soon, since this was just released in Chrome 94, I think.
Yeah, definitely. I would head over to our there's a group called Blink Dev at chromium.org, where we announce like everything that's happening in Chrome, and when we ship new APIs, for web codecs in particular, when I was going to ship this in Chrome 94, I had to announce it and then get approvals, and part of that announcement, there's kind of a back and forth. You have to convince the API approvers, like, okay, yes, this is okay to ship. And but what's interesting, to answer your specific question, is I listed a bunch of folks that are actively using the API, that are really excited about it. This included Zoom, Citrix, Clipchamp, which is on the movie editing side, Visor, which does a low latency desktop, like use your Android phone on your desktop type app, and a couple of others. That's a cool list, because you can see some names you'll recognize, and then you can also see in their own words what they like about the API.
Nice. Very cool. Question from Alex. Alex says, currently WebRTC decides itself on frame size based on CPU usage. Could this be worked around with new and upcoming APIs?
Yeah, so this is like, you take Zoom as an example. Like if you build your entire RTC stack from scratch, and you use WebCodecs at the bottom of that stack, you are obviously making all the decisions about what size of frames you're encoding, and WebCodecs is happy to encode at whatever size you've instructed. I phrase the answer that way because the answer is yes, but it isn't a small yes. It isn't yes, and you can go make a small change to your app to use WebCodecs and achieve exactly what you want. It is
right.
Start from the Codec API and build up from there.
Yeah. No, and that's a really important disclaimer, and I certainly appreciate it. I'll give that disclaimer to any of our clients watching this as well. There's a lot of cool things we could do with WebCodecs. It may not be easy or fast. But definitely some awesome possibilities there. Another thing, one of the questions here, kind of around use cases. One possible use case are kind of tools like we're in right now for doing a broadcasting, and where we may want to do some manipulation to the video, like maybe adding video overlays of who's talking on top of our videos, or funny hats examples, or captions, or anything like that we may want to add into the video. Talk a little bit about how the difference between how we used to do something like that, or kind of currently do, with the use of a canvas versus what we can do with WebCodecs if we build at a little lower level.
Yeah. So you could have done this even before WebCodecs, and years ago, using get user media and then piping that to video tag, and then grabbing the video frame from the video tag using Canvas, and that works, but it is not super efficient. So if you have video coming from a video frame, from a camera, that video is likely going to be in some YUV format, where Canvas is entirely an RGB thing. So right away you've got a copy and a format conversion, and then it's not ideal. So with WebCodecs and Media Stream Track Generator processor, rather, we're going to give you the frame in its native format. Like, this is kind of an underlying principle of WebCodecs. We try to avoid any kind of format conversion, just give you exactly what we have natively, be a low-level API. You can still take that and draw it to Canvas. A video frame is a Canvas image source, so you can call draw image on a canvas and you paint the video frame. But you can also send that video frame to WebGL using TextImage 2D or any of the other Canvas image source type APIs, and skip some of the conversion steps that were happening previously. Or let's say if you have a WASM, like machine learning stack that is identifying, helping you with background replacement or identifying the position of the face. And that's what you're going to use to actually draw the funny hat. You can copy without conversion, the YUV data out of the video frame, apply your transformation, and then create a new video frame and send that up into your RTC stack or into your custom build, whatever you've got going. In the future, many of you probably heard about WebGPU. We're actively, WebGPU isn't a shipped API yet, but we're actually thinking about this as well. How can we upload, it's not exactly the right word because it may already be in the GPU, but a video frame into WebGPU for you then to run shaders on and manipulate. So you should expect that will be possible when WebGPU ultimately becomes available.
Very cool. Very cool. Excellent. Well, thanks so much for joining us today, Chris. Any others sort of closing thoughts on your part or things you want to point out in upcoming releases or anything like that we should be aware of?
Yeah, I just want to encourage everybody to take a look at the spec and identify gaps that we have. We have launched our V1. Folks are using it. Please do use it. But also we know that the work is not done. And if you see an important feature that you need, please file a bug. If you see a bug already filed, pile on. Keep me employed. We want to make this better. That's it.
Excellent. All right. Thanks so much for joining us today, Chris. Really appreciate you sharing with us about what WebRTC developers need to know about WebCodecs, how we can utilize it, really interesting views into the future and how to do some things just more efficiently than we can do them now. So we always appreciate that as developers. So we'll post this video soon to YouTube as well as to our blog. Our next episode of WebRTC Live will be on Wednesday, November 10th. We'll be speaking with Arin Sime from callstats.io and 8x8. If you want to find out more about our upcoming episodes, follow us on Twitter at WebRTC.Ventures. Join our email list at WebRTC.Ventures. Thank you, everyone, for joining us today. Let's make it live.
Thanks for joining us for WebRTC Live. Visit our website at WebRTC.Ventures to learn more about our custom design and development services and to learn more about upcoming episodes of WebRTC Live.